right, welcome everyone. Hi, thank you for coming. This is the Linkerd project update. My name is Linkerd. My name is Alex Leong. I'm a project maintainer on Linkerd. I'm a software engineer at Buoyant, and I'm happy to be giving this update on kind of all the things that are new and going on with the Linkerd project. It's been a really busy year for us. The pace of execution on this project has just been like through the roof, so there's a lot to talk about. There have been, in fact, a lot of things going on with Linkerd at this KubeCon, so we're kind of towards the end of the week now, but we've had a whole bunch of talks all through the week. We had a great Linkerd Day back on Tuesday, a lot of really cool talks there. On Wednesday, there were a couple of talks. I gave one, William Morgan gave the other. Those recordings, if you weren't able to make it to those, I highly recommend you check those out when the recordings are available. And then here we are on Thursday. This is the Linkerd update, where I'm just going to give kind of a overview of where the project is at, what's new, what's going on, and what's coming up. Of course, we're also in the expo hall, so if you have more questions about Linkerd, come find us there, and happy to chat about all things service mesh. If you don't already know what Linkerd is, it is a service mesh, so it's ultra light, ultra fast, security first is our positioning. It's built specifically for Kubernetes, so it's Kubernetes native. It's been in production for 8 years now at a variety of different companies at various different scales and in various different environments. So it's definitely battle tested and battle hardened. We're a CNCF project, we're graduated, and I'm really proud of the work that we do on it. And to kind of summarize, like in a nutshell, where we think Linkerd is positioned as a service mesh, we want it to give every platform engineer in the world the tools they need to create a secure, reliable, and observable cloud-native platform. And all three of those pieces are kind of critical. You can't compromise on one to get another. So the design philosophy for Linkerd is that it should just work. You should just be able to install it without using your brain, and it should just kind of work right away. There's a lot of tools out there that require a lot of configuration, and Linkerd can be one of them, but you should kind of have to scale up the config that is required based on what your needs are. And easy things should be easy. More complex things are there when you're ready for them. Another philosophy is to not be greedy, right? When we're talking about a service mesh, in the case of Linkerd, we have a sidecar proxy. And that means that proxy is in every single pod in your application, in your cluster. And so, at that scale, it's very easy, as software developers to be like, well, computers are powerful, memory is cheap, who cares, let's just do whatever. But in the sidecar environment, every byte matters. And when you're talking about intercepting traffic, and all your requests are flowing through that proxy, then every millisecond, every microsecond matters. So we really are always conscious of that and trying to use the minimum amount of resources that we possibly can. I think maybe the most important of these is removing operational complexity. So any kind of cloud-native application is, certainly going to be complex. There are a lot of moving pieces. There are a lot of different technologies in play. There's a lot for you as a developer or as an operator to be aware of, and we don't want Linkerd to be kind of an extra thing that makes your life harder. We want it to be something that makes your life easier. So to whatever degree possible, we want to make that easy to operate, have it just kind of do what you expect and be predictable. And security has to be there out of the box. That's non-negotiable. We don't want insecure traffic out there, and we don't want it to be difficult to secure your traffic. So if you install Linkerd, you get MTLS by default, no configuration necessary. It's just there. And so what kind of makes Linkerd unique in this space is that we have our own proxy that we wrote specifically for Linkerd. So this was written in Rust. We call it a micro proxy because it is designed to be as lightweight and out of the way as possible. So we don't use Envoy. We use this Rust proxy. And it was written to be security first. That was the reason, or one of the reasons we chose Rust as the implementation language, is because we wanted to make sure, to whatever degree possible, that we didn't have memory safety issues, that we could be really deliberate about the memory we were using and using it in a safe and efficient way. This is built on state-of-the-art networking stack, so we use libraries from Rust like Tokyo, Hyper, H2, and Tower. We use state-of-the-art crypto libraries to do MTLS, and it's a very modern and I think cutting-edge project. But this is all to say the proxy isn't something that anyone who uses Linkerd should ever have to worry about. You know, this should be an implementation detail. The service mesh should do its thing, and you shouldn't have to care that the proxy is written in Rust or written in Go or written in C or written in whatever. It should just get out of the way, consume minimal resources, and do its job. Okay, so Linkerd year in review. What has happened in the last year since KubeCon Paris? It's a lot. So we released Linkerd 2.16. This release had a bunch of stuff in it. Maybe most notable was that we took a lot of the functionality that was in Linkerd for per route behavior, like per route retries, per route timeouts, per route metrics. All of the stuff that was previously configured in Linkerd using something called service profiles, those we're trying to deprecate and move away from, and move everything onto a more commonly used API, which is the Gateway API. So we want the Gateway API to be the common way to configure a lot of these things in Linkerd so that you can get per HTTP route, per gRPC route, or even TCP, TLS routes, and have all that configuration live on the Gateway API so that we can kind of integrate with the rest of the ecosystem. So that was added in 2.16. We also added support for IPv6, so that's part of Linkerd now. We added a policy audit mode. So Linkerd has authorization policies, so you can configure traffic to be allowed or denied, but these are very scary to implement because if you want to switch your default policy to default deny, which is a good thing to do from a security posture position, it's very scary because if you haven't set up those policies correctly, you're going to start denying traffic that you shouldn't be denying and your application will break. So we've added this audit policy mode where you can say, well, let me set up my audit, my policy, my security policy, but instead of denying things, instead just let them through, but tell me about it, so that you can make sure that your authorization policies are configured correctly. Once you're satisfied with that, then you can go ahead and switch to default deny, and you'll have confidence that you're not going to break your application in doing so. And since we were moving retries over onto HTTP route and gRPC route anyway, we kind of did a little bit of cleanup and restructured the way that's configured to make it more in line with how the proxy is architected. In Linkerd 2.17, we added egress, rate limiting, and federated services. So this was a big release with 3 very large features. So I'm going to spend some more time in later slides talking about each of these in more detail, but each one of these is very large. Linkerd 2.18 is not released yet. We're still putting the finishing touches on this, but it should be released very, very soon. We kind of had to put some of the work here on hold in order to come to KubeCon and talk here. So as soon as I'm back home, this is going to go out very quickly. But Linkerd 2.18 added a more GitOps friendly way to do Linkerd Multicluster. So there were some aspects of Linkerd Multicluster that were not compatible with GitOps, and we wanted to remedy that. We did some more work on the way that Linkerd interacts with the Gateway API, and I'll talk more about that in a moment. And we added protocol declarations to Linkerd so that you can annotate your traffic as a specific protocol in order to avoid protocol detection. I'll talk more about that too. So this release will be out very, very soon. Okay, so to dive a little bit deeper into egress metrics. So we added this new resource type to capture traffic which is leaving the mesh, which is going from inside your meshed workloads to something outside. And so we have this new CRD, this new resource type called egress network, and this allows you to describe that traffic. And so with an egress network, you can attach routes to it, and you can get metrics on all the traffic that's leaving your cluster, right? So this is a degree of observability that you didn't have before. And you can capture, for example, like TLS host names in those metrics. You can see which host names, which TLS names is my application talking to outside the mesh, and you can do an audit of that, for example. It also allows you to control that traffic that's leaving the mesh, so you can disallow certain traffic So you can have this, for example, in this example, or here we have traffic policy deny, which means we're going to deny all of the traffic leaving the mesh, but then we can add exceptions to that. So we added a TLS route here on the right-hand side that allows traffic to http bin.org if it's TLS'd, for example. So it gives you that egress access control. And so for traffic leaving the mesh, you can decide what's allowed to go out and what's not. We added some server-side rate limiting. So this is a new resource type called the HTTP local rate limit policy. These policies let you specify rate limits, either global rate limits or per client rate limits that let you protect your service from undue load by saying, hey, this is the maximum amount of requests per second that we want to let in. And if more than that come in, then Linkerd can kind of act as a barrier there and reject those requests before they get to your application and protect you from that heavy load. We also added these things called federated services. I gave a talk about federated services, doing a deep dive on this on Tuesday at Linkerd Day. So if you want more details about this, well, there's lots of docs online, but you can also go and find that recording where I kind of dive really deep into this feature and exactly how it works and why it was necessary, what motivated it. But the basic idea here is that if you've got a service that's deployed to multiple different clusters, multiple different Kubernetes clusters, and that service has the same name and the same namespace across all of those clusters, you can merge those together into what's called a federated service. And a federated service is then just going to simply load balance over all of the endpoints of all of those services in all of those remote clusters. So this is a multi-cluster feature that lets you kind of interact with the service in a cluster agnostic way. So you're saying, I want to talk to this service. I don't care which cluster it's running in. In fact, it's running in multiple clusters, and I just want to access that service as a whole. And then if one of those clusters goes down, or if one of those clusters is slow, that load balancing will kick in, and that service will remain available even if clusters join, clusters leave. It's dynamic in that way. And we added protocol declarations. So this is actually really cool. So one of the things that Linkerd needs to know when it's routing traffic is it needs to know what protocol the traffic is. And so typically it does this with something called protocol detection, where it will just look at the bytes that are coming in on that connection and say, hey, do these bytes look like HTTP? Because HTTP requests always start a certain way. And if they do, then, okay, it's HTTP, we'll treat it as such. We'll do HTTP-based routing, we'll collect HTTP-based metrics, we'll do all that layer 7 good stuff. And if it's not, then we'll treat it as TCP. We'll say, okay, well, this is some other protocol, it's not HTTP, so we're going to instead just gather more basic L4 type of metrics, so just bytes and so on. And this is really great. It works very well 97% of the time. But there are a bunch of edge cases where this doesn't work. And if you've ever run into protocol detection timeouts and seen weirdness as a result of that, you know what I'm talking about. And so one of the ways that people have worked around this issue is we have this feature called opaque ports. And so there's a configuration where you can say, this port here, just treat it as opaque. Don't try and do protocol detection on it. Don't worry about what protocol it is. Just forward it through. Just treat it as TCP. Don't worry about it. Don't do all that stuff. And that works really great, but until now, we didn't have any way to do the opposite of that. We didn't have a way to mark a port as, hey, this is HTTP. Don't try and detect it. Just believe me. I'm telling you. And so please do all that layer 7 stuff for this connection. It's HTTP. Don't do the detection. So that's what we've added here. We've added protocol declarations. These are, they make use of the app protocol field in the service resource. So for any Kubernetes service, there is a app protocol field, and now you can specify in that field what the protocol is. And if you specify HTTP or opaque, then we will not do protocol detection. We'll just use whatever's in that field. So this is especially useful for workloads that run right at the edge of your resource limits, because when resources are very constrained is kind of one of the common cases that protocol detection can fail. We also added GitOps compatible multi-cluster linking. So if you've used the Linkerd multi-cluster, the way that it works is that step 1 is you install the Linkerd multi-cluster extension, and then step 2 is you have to link together all the clusters that you want to be able to talk to each other. This is very straightforward, but it involves running this command, Linkerd multi-cluster link. And so you have to establish all these links. If you have 3 different clusters that all talk to each other, that's one link in each direction between all the different clusters. And if you're just doing this, it works great, it's fine. But if you want a GitOps compatible setup, then you want to somehow specify that declaratively. You don't want to have to run the install and then this separate linking step. And it's kind of even worse than that, because when you upgrade Linkerd, you also have to upgrade the Linkerd multi-cluster extension, and then you also have to upgrade each one of these links individually. So we've rearranged the way that this is structured so that those links are now part of the Linkerd multi-cluster chart itself. So you have to specify those links as values in the Linkerd multi-cluster Helm chart. But now that's all kind of part of that chart. And so when that chart gets upgraded, all of the links get upgraded. It's much more GitOps friendly, so it's going to work with whatever GitOps workflow you have. So we think about this as being declarative instead of imperative. So instead of doing the second step of linking, that's just all specified in the values. And we've done a lot of work on the Gateway API to bring it up to a modern version. So previously, we were reading fairly old versions of the Gateway API resources. I think we were using like the v0.7 release of Gateway API and whatever resource versions were in that. We've upgraded to now read the v1 versions of HTTP route and gRPC route. So that's compatible with a wider range of more modern versions of the Gateway API. So if you have anywhere between version 1 and version 1.2.1 of Gateway API, that's now going to be compatible with Linkerd. And we're also compatible with both the standard and the experimental channels. The experimental channels have TCP route and TLS route in them. So if you want to make use of those types, you need to use the experimental channel. Otherwise, you can use standard. And we're also kind of shifting our philosophy on how the Gateway API is installed. So previously, whenever you install Linkerd by default, it would come with the Gateway API CRDs. We would bring those along and install them for you. And increasingly, we've heard feedback that that's not what people want, because they either already have these CRDs installed on their cluster, or they're being provided by some other project, by their ingress or by their gateway or by something else. And so we really are kind of moving to this world where the Gateway APIs are a prerequisite. They're something that already exists on the cluster, and we can just interact with them. And we don't have different projects kind of fighting over who should be installing these and making sure they're there. So we're kind of going through this transition period right now where we want those to be provided already. We're just going to kind of assume they exist. We'll do some checks to make sure and warn you if they're not. But we want to treat those as an external dependency, and we can like kind of help you through that process and give some helpful error messages that say, hey, we detected the Gateway API resources that we need are not available. Here's how you install them. Here's where you get them from. And so by the next version of Linkerd, which is Linkerd 2.19, we're no longer going to be installing those by default. So we want to kind of roll this out in a way that is safe and is not going to break anyone on upgrade. But that's kind of what we're moving towards. And then just kind of talking about the Linkerd project as a whole on a somewhat more meta level. What's really exciting is that Linkerd is now, we say, is a sustainable project. So Linkerd is developed primarily by one company, which is Buoyant. That is who signs my paychecks and funds all of my work on Linkerd. And Buoyant is now, as of fairly recently, a profitable company. And so I think that gives the project a lot more confidence in its sustainability and its longevity because there's a sustainable company funding it. And I think we've already seen like dividends on that. We've seen the pace of execution on Linkerd really, really increase as a result. Buoyant has had more resources in order to hire maintainers and increase project output. And so it's really great to have a project that has dollars and cents behind it. Linkerd has been around for almost 10 years. I think so as William Morgan, our CEO, added this line, we're aiming for another 90. Yeah, I mean, I think it's a project that we want people to have confidence is going to be around. It's not going to go away tomorrow when all of the funding goes away or all of the maintainers don't have a job anymore. That's not a situation we're in, and I'm really grateful for that. Linkerd does weekly releases, so if you've ever seen this kind of format, edge-25-.4.1, this is our release naming format for our weekly edges. That means the 25th year, the 4th month, and the first release of that month. So this would be the first release in April 2025. When we release these edges, they're released off of main. So all of the latest bug fixes, all of the latest features, all of the latest security patches, everything that's kind of on main at that point in time is released in those edges. And the idea is that every edge release is intended to be production ready. These are not kind of experimental releases or beta or unstable. Everything that gets merged to main is supposed to be of production level quality. So this is all code that has been battle tested and we're confident in and we stand behind. We also kind of bundle up features into these releases. So we have these whatever releases, 2.18, for example, that kind of represents a finished feature, or not finished, but a cohesive feature. And we kind of iterate on these, as you saw in the example. Sometimes we'll release a feature in one release and kind of iterate and improve it in the next. But each of these is meant to be somewhat self-contained and cohesive. And that's also kind of the time when we take a pause on feature work in order to document what we have and make sure that it's usable and that it is documented and people know how to consume it. So every version has a corresponding edge release and also has a Git tag. So there's kind of a record through the Git history of where all the releases are and what edges they correspond to. Okay, so what's coming next for Linkerd? That's where we are now. That's all the million things we did in the last year. And like there's so much on the horizon, and there's so much work to do. So one of the biggest things on our roadmap is to continue to flesh out Windows support. So right now, this has been in progress for a little while. The Linkerd proxy runs on Windows. That took some doing. But of course, the proxy is not the entire service mesh. There's more to the service mesh than just the proxy. So there's still more work to do to make sure that we can say confidently, Linkerd, the service mesh, will run in Windows environments. So that's in progress. We want Linkerd to do more with the ingress use case. So right now for ingress, what a lot of people do is they'll have some kind of ingress controller like Nginx or something else. And then they'll also have that is a meshed workload. So they'll also have a Linkerd proxy running alongside it. And so incoming connections into that ingress have TLS terminated by Nginx or whatever. And then for the east-west traffic going out of there, Linkerd kind of takes over and does like workload-based MTLS from there on out. And so the question is, well, why do you need two proxies there that one hands off to the other? Why can't Linkerd do everything? So moving more into that ingress use case is definitely something on our roadmap that we would like to explore. We want to do egress TLS origination. So whenever you have a workload that's talking to some kind of external egress TLS identity, so say you're talking to, get https.github.com or whatever, that is TLS that's originated by your application. And so when the Linkerd proxy intercepts that connection, it's encrypted, right? And it should be, because that's how TLS works, which means we can't read the specifics of those bytes. We don't know what's going on there. We can't do layer 7 metrics collection, layer 7 load balancing, or anything really intelligent with that traffic. So we kind of want the ability to say, well, if you just send a plain unencrypted request to us, we will originate the TLS to that external host. And then we kind of, because we can see those requests, we can see that traffic, we can do all that layer 7 load balancing, layer 7 metrics, layer 7 routing, all of that good stuff. But it's still, encrypted to the destination. We have a feature called mesh expansion, which I didn't talk about because it was not added this year, which allows you to have workloads that run outside of Kubernetes be part of the mesh. That's a very exciting piece of work that we're continuing to improve and iterate on. We want to add support for private networks to that, so that if you've got workloads that are running on private networks outside of Kubernetes, those can be part of the mesh too. There's still more to do on link management. I think, in 2.18, we're doing a lot to make that more GitOps friendly. there's still more to do to make that even easier to work with. We want to do more with using Spiffy for identity inside the cluster. So if you're using mesh expansion, Spiffy is the identity provider we use for those workloads that are running outside of Kubernetes. But we also want to explore if we can use Spiffy for identity inside the cluster as well, and kind of bring those together. And then to kind of add more flexibility and configuration to the way federated services work. So federated services are very powerful, but they're also a little bit rigid in the way that they operate. Every service that joins the federated service has to have the same name and namespace in order to be merged together. When they do that, the service that's created, the federated service that's created as a result of that, is called that service name -federated, and that's kind of hard-coded name. So we want to add a little bit more flexibility there so you can kind of control how that works and make sure that it suits your use case. So that's kind of the things that are immediately on our roadmap, but of course, that roadmap is very dynamic, it's always in flux, and it's always adapted to what users are telling us they want. So this is, definitely a two-way street where we're always interested in hearing what people are doing with Linkerd, what they want to do with Linkerd that they can't, and that definitely informs and adjusts our roadmap as time goes on. So if there's anything on this slide or anything at all that is of interest to you, that you really want to come talk about, please come to the Linkerd booth, come to the Buoyant booth, come tell us what your use case is, so we can have that information when we're planning our roadmap, or open a ticket on GitHub, come to the Linkerd Slack, just get in touch with us any way you can and be part of this project. If you want more information about Linkerd, we have a Service Mesh Academy, which is a self-paced online course. You can get certified in Linkerd. There's some really good educational materials there. It's a really nice course. You'll definitely learn a lot no matter where you are in your service mesh journey. If you go to buoyant.io/SMA, you can sign up. And I'm happy to take any questions you might have right now. Yeah, there's a mic right there if you can repeat. Yeah. Okay, I heard you, so I'll repeat your question. The question is there a performance advantage to using protocol?
Sorry, it's on.
Thanks. Yeah, essentially, can we shave like 5 milliseconds off of every request across the cluster if we enable protocol declarations, or is the trade-off with the complexity not worthwhile?
Yeah, that's a great question. I think the answer is it depends a little bit. So in the good case, in the ideal case, no, because protocol detection happens basically instantly. As we read those bytes, we immediately know what the protocol is. So in the golden path, there's no difference. Where things start to matter is where things are not in that golden path. And so where, for whatever reason, those bytes don't get written to the connection immediately, we're not able to detect that connection. And so Linkerd will actually have a 10-second timeout while we wait for bytes so that we know what this protocol is. And if we don't get anything in those 10 seconds, we'll give up and say, okay, well, it's just TCP, I guess. And so when we're in those cases, we actually incur a 10-second delay on connection establishment. And so that delay is what we can avoid by just saying, hey, don't try and do detection on this. Just believe me, it's this protocol.
Got it. Okay, thanks.
Thank you, great talk. I have a question related to multicluster and federated services. So in our case, we would have up to hundreds of devices, and each device is a cluster. And how you ensure that this functionality is backward compatible, because if we combine all of these clusters and we cannot update them all at once, yeah. So they have different versions of Linkerd, yeah. And that means this multi-cluster still has to work.
Yeah, that's a great question. So, and it's something that we always think about when we're adding features that exist in one version and don't exist in another, is kind of what is the upgrade story between those, and in particular, like what happens when some of those clusters have been upgraded and some have not. Sorry. So yes, that's something that's always on our mind. We know that people will be running in these transitory states where some clusters are upgraded and some are not, and they have to be able to continue to work together.
Anyone else?
All right, thank you very much.